Imagine a world where you can transform your wildest ideas into reality with just the push of a button, a world where objects materialize layer by layer, defying the boundaries of traditional manufacturing. Welcome to the mesmerizing journey into the history of how 3D printers are made. From the dawn of Chuck Hull's groundbreaking invention to the cutting-edge technology of today, we're about to unveil the incredible evolution of 3D printer manufacturing. Get ready to witness the birth of innovation, the rise of open-source pioneers, and the promises of a sustainable, automated future. This is not just a story of machines, it's a story of limitless possibilities. So, join us as we embark on a voyage through time and technology and discover how the world of 3D printers is made. Our story begins in the 1980s, when 3D printing technology was in its infancy. In 1983, American engineer Chuck Hull introduced the concept of stereolithography, a breakthrough that laid the foundation for what we now know as 3D printing. Hull's invention gave birth to the world's first 3D printer, a massive machine that utilized ultraviolet light to cure layers of photopolymer resin. However, these early machines were far from the compact, efficient printers we have today. Moving forward to the late 80s and early 90s, we saw the emergence of commercially available 3D printers. These machines were initially limited to industrial applications, primarily for prototyping. Evolution of materials. In the early days of 3D printing, the materials used were relatively limited. Photopolymer resin was the primary material. However, as the technology progressed, so did the range of materials. By the late 90s, the introduction of thermoplastics marked a significant turning point. This development revolutionized 3D printing by enabling the creation of durable, functional parts. The manufacturing of 3D printers evolved to accommodate these new material options. This required more precise extruders and heated print beds to ensure the quality of prints. Advancements in extruder technology. The heart of a 3D printer is its extruder, and over the years, extruder technology has undergone significant improvements. Early extruders were relatively basic, lacking the precision and reliability of modern counterparts. Today, we have state-of-the-art extruders featuring multiple nozzles, advanced temperature control, and sophisticated filament feeding mechanisms. These advancements have contributed to higher quality prints and increased printing speed. Electronics and control systems. 3D printers rely heavily on electronics and control systems. In the early days, control boards were relatively simple, with limited processing power and capabilities. Today's 3D printers are equipped with advanced control boards that can interpret complex instructions, perform real-time adjustments, and even connect to the internet for remote monitoring and control. Bed and print surface. Another crucial aspect of 3D printer manufacturing is the bed and print surface. Early 3D printers often used heated glass beds, but these had limitations in terms of print adhesion. Modern 3D printers feature various types of print surfaces, including heated build plates with specialized coatings like PEI or build talc. These surfaces ensure proper adhesion and easy print removal. Expansion into consumer market. By the mid-2000s, 3D printing technology became more accessible to consumers. Desktop 3D printers entered the market, making it possible for hobbyists and small businesses to create their own 3D printed objects. These early desktop 3D printers were often DIY kits, requiring assembly and calibration by the user. Despite their limitations, they marked a significant step towards democratizing 3D printing. Some schools also have 3D printers right now. They use it for education or just for making something they can use in their own lesson. Manufacturers adapted to this growing consumer demand, focusing on producing affordable and user-friendly 3D printers. This shift required streamlining manufacturing processes to lower production costs. The rise of open-source 3D printers. A pivotal development in the history of 3D printer manufacturing was the rise of open-source 3D printers. Open-source initiatives, such as the RepRap project, provided blueprints and software for 3D printer designs that anyone could use and modify. Open source movement not only fostered innovation, but also influenced commercial 3D printer manufacturers to adopt more open and collaborative approaches. 3D printing in industry. As 3D printing technology matured, industries worldwide began integrating it into their manufacturing processes. Large-scale industrial 3D printers became capable of producing complex parts for aerospace, automotive, and medical sectors. The manufacturing of these industrial giants required a focus on precision engineering, heavy-duty components, and quality control. Sustainable materials and practices. With environmental concerns on the rise, the 3D printing industry has also been evolving towards sustainability. In recent years, there has been a push for more sustainable 3D printing materials and practices. Manufacturers have been exploring biodegradable filaments, recycling options for failed prints, and energy-efficient production processes to reduce the ecological footprint of 3D printer manufacturing. The digital revolution. In today's digital age, 3D printer manufacturing is intertwined with digital technologies. The evolution of 3D modeling software has greatly impacted 3D printer production. Designers now use advanced software to create intricate 3D printer components and optimize their functionality. Computer-aided design, CAD, and computer-aided manufacturing, CAM, have streamlined the production process, enabling manufacturers to quickly adapt to design changes and improvements. Challenges and future prospects. Despite all the advancements, 3D printer manufacturing still faces challenges and holds exciting prospects for the future. Research and development continue to be essential in the 3D printer manufacturing industry. Manufacturers are constantly striving to enhance various aspects of 3D printing technology. One area of focus is materials innovation. Throughout history, we've seen a significant evolution in the types of materials used for 3D printing. From photopolymers to thermoplastics to advanced composite materials, R&D labs are exploring new materials with improved strength, flexibility, and even electrical conductivity. Extruder technology is also under constant refinement. The pursuit of faster print speeds, finer layer resolutions, and greater precision continues to drive extruder advancements. In the early days, 3D printers were often large, cumbersome machines. However, the future holds the promise of compact, portable 3D printers that can easily fit on a desk or in a classroom. The trend toward miniaturization is already underway, with manufacturers focusing on producing smaller, more affordable 3D printers that can cater to educational institutions, creative professionals, and hobbyists. Sustainability remains a pressing concern, and 3D printer manufacturing is actively seeking eco-friendly solutions. The future may see the widespread adoption of recycled or biodegradable filaments, as well as improvements in energy efficiency during production. Furthermore, advancements in automation and artificial intelligence are poised to revolutionize 3D printer manufacturing. Smart assembly lines with robots capable of intricate tasks could further streamline the production process, reducing human error and improving efficiency. The journey of how 3D printers are made is a story of relentless innovation, accessibility, and boundless potential. From the monumental inventions of pioneers like Chuck Hull to the intricate workings of modern machines, the 3D printing industry continues to redefine the way we create and manufacture objects. Thank you for joining us on this comprehensive exploration of the history and future of 3D printer manufacturing. If you found this video informative and engaging, please don't forget to like, subscribe, and hit that notification bell for more captivating content.